Hello, everyone. Welcome back to the fourth episode of Great Backend Engineering Podcast. So, in this episode, we are going to be talking about the importance of data structures and algorithms to backend engineers. Now, there is this misconceptions that backend engineers don't really use the data structures and algorithms that are given to them during work interviews. And today, we are going to clear these misconceptions. I have with me here Fernando Francisco, which is going to talk to us about data structures and algorithms and how important they are to backend engineers. So, Fernando, please introduce yourself.
Hi everyone, I'm Fernando Franco, and I'm a software developer. Uh, Now I have almost 15 years of experience in the field, and I started working as in Italy for the university. I did a PhD in computer vision and image processing, and I started working there, implementing some algorithms for people tracking and object detection. Then I moved a bit to a different field. I started joining the industry, and I work 5 6 years as an embedded software developer, developing software for train, locomotives, and airplanes, such kind of things. And after that, and moving from Italy to Switzerland, I now working in the medical devices field, and I'm back to more traditional backend task, working on business logic or infrastructure, and we mainly develop product for radiotherapy, that is cancer treatment, and I work a lot with, again, it's image processing or manipulation of 2D 3D images. That's in a few words what I did in the past 15 years. And yeah, I'm glad to be here with you and talk about this topic, since I'm anyway I've been always passionate about algorithms and data structure, even not from the beginning. I could tell an anecdote about this, but it was not that I started loving this stuff from the scratch. It was
All
also
right.
there. Yeah.
All right. So yeah, honestly, I've benefited a lot from your short tutorials on Twitter, where you break down lots of kind of complex topics. I refer them as complex topics because they are really topics that people don't want to talk about, but then you have decided to talk about them, and there are data structures and algorithm and other important topics around backend engineering. And that's why I reach out so that you can help other backend engineers break it down even further. All right, so before we get started, this podcast is sponsored by Mastering Backend Academy. It's a platform where we train you to become a great backend engineer. So the links are going to be in. Okay, so Fernando, I have a very important question for you. First,
Hmm.
I want to get to know how you actually get started in backend in software engineering. So I understand that you said a few things when you were introducing yourself, but I want you to tell us how it all started, like from day one, the choices that you have to make to get to this stage, and possibly the journey itself. So tell us, how did you get started? How did you get started in software engineering?
Yeah, I mean, for me, it was more. Of course, I took a CS degree at university. Even if I have to say, I was not probably fully aware of what expecting from from this CS degree. And in the traditional path that we have, at least in Italy, where we're studying this, there is a lot of also maths or concept not strictly relating to computer science, and it was a bit tough at the beginning to tackle all this. But I mean, let's say after that, what changed my path was really the end of the studies, where I did my master thesis on this computer vision stuff, and that make me really get passionate about that field, and wanted me to continue to work there. And then I was happy while doing this kind of job at the university, but I was not so much convinced about the let's say this academic path, because if you stay at the university, you get a bit disconnected from the industry. And when I got this possibility from a big company like General Electric to join them, even if it was not strictly related to what I studied at the time, at that job, I was not doing computer vision. I decided to join them, and that was really lucky things, because I could learn really a lot from the job, from software engineering point of view, really, from software development for best practice, for how, I mean, whatever really testing or development. It was really good training for me. And
Mm,
yeah, I mean, what I can say is that probably it really depends. Everyone has its own path, for becoming a software engineer. And for me, the path was quite traditional. I went to university. I was appreciated by the professor, and I started working with him. And then I got the first offer, and I started
mm,
uh, be in the industry. And once you are there, then I think a lot of the struggle is to get into the industry for people that maybe has not a traditional path. But once you are there and start developing experience, then it gets much easier, no? And
yes.
yeah, and that
Yeah.
was important also for me, for my experience in this approach with computer vision, was also, I mean, to appreciate more how useful algorithms and data structure can be, because this is what I wanted to say at the beginning. When I studied the first time this topic during my CS degree, I also had I wasn't like a lot of these things, because where sounds to me like abstract, and say, why do you need to learn all these kind of complex things? Why do you need to understand how a binary search tree works, or why do you need to study all this how to
Mm,
insert node into so all the, but because yeah, this is the traditional approach also of the university. Do you study these things from theoretical point of view, but you completely miss the practical side. You are and then when we computer vision, I really started to see this structure in use every day, and say, okay, I really need to get better at these things, no?
yeah, yeah. Yeah. So I think the job can actually give you a direction when it comes to software engineering. So you get started with one thing, and then the job requires more other things. So you don't have a
Yes.
choice than to go learn them. And that's why these experiences are really, really awesome, because it gives you a kind of a sense of direction. So if you kind of story around how I started. So basically, I think I started off just from there's something they call skill acquisition programs, where people go and instead of persons just train them on some skills. So I started there, and I kind of fell in love with the entire idea of building something and having it shown online. The web development aspect, and I grew with that. So I went to the university to study computer science, but I think we didn't really learn anything that relates to that relates to quickly building out systems. right? But we kind of learned the theoretical part of what we needed. Like we, like we learned about system designs and data system designs and data structure. We learn about algorithms. We learn about all these, but it wasn't practical. Okay, so I had to learn the practical aspect of these things, working in a job or kind of wanting to have more knowledge around it myself. Okay, so yeah, it's nice. It's awesome that you shared your experience on how you got started in backend engineering. Now that we are talking about data structures and algorithm, that's the main topic of today. I want to start by asking, can you start by explaining why data structures and algorithms are important for backend engineers?
Yeah, sure. I mean, when talking about this, I think we 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 first need to talk about two different planes. First of all, I mean, let's first talk about the technical side. So, I mean, about that algorithm data structure. And
Mm,
for me, there are probably when people refer to do you really need to know algorithm data structure, they refer to more advanced topic, because for me there are basic things that there is no way that a software developer should not know exactly how they work. I mean, if you talk about arrays, dynamic arrays, or linked list, or queue stacks, these kind of things. I mean, it's not super fancy or complex task, and you need to know how they works, how they are differently stored in memory. It's what is the I mean, what does it mean when you that you can access an element of the array in constant time, and sometimes you also need to implement. I mean, it's not for as again the other, let me stop here with this, and the other things that I want to say is that apart from the technical side, it also depends a lot on which kind of job you are doing, because also there backend development, it's not it's a vast field. It's not that every of us do the same job of the other, no. And it depends a bit of if you are only doing work of integrating existing stuff into a system, or if you want if you are implementing business logic, or you are developing also core part of the system. Maybe you are working on a database engine, or I don't know. I mean, all of these things could be part of backend development. So, and of course, the the kind of algorithm, the kind of advanced algorithm data structure that you need to know, it depends then on the field you are working on, no. And there are if you're working on business logic, computer vision, as I do, you need to know more about some stuff. If you work on database development, you need to know more about other stuff. But the thing
yes.
is that in any case, as I keep repeating, the basic stuff for me, there is no way that people shouldn't shouldn't know. This is a part of should be part of the background of every software engineer. For
Mhm,
the more advanced stuff, the things that I can say that I notice also in my career is that it is the more you. It also depends which kind of developer you want to have. The more you know, the more it opens also opportunity to you to work on different things, on interesting things,
mm,
and also to optimize or improve the system you're working on. I mean, because saying that you don't need to know algorithm data structure, it's also a kind of bit like of self-fulfilling prophecy. You say you are you are not using them because you don't. If you don't know about them, you don't know when they are helpful, and you don't know how using one structure instead of another, it could make your system better, or your code simpler, or more efficient, or whatever. No. So
mm,
uh, I mean, for me, absolutely, if the answer is that a backend engineer need to know about algorithm structure, I would say yes. it's much better for you
Yeah,
if you know this. Otherwise, you don't even know why they could when they come handy to you. No?
yeah. So from what you said, right, I could quickly understand that it's really important that you know them. But of course, since they are very kind of difficult to learn and they take time, so it's better you approach them one after the other. Okay. And
Hmm.
sometimes when you are writing systems, you might actually be using some kind of algorithms, but you don't even know. Right? You don't
Yeah.
even know that stuff that you are writing kind of have an algorithm or is an algorithm somewhere. Okay, for example, if you are given an kind of a list of array and you have to manipulate it to get data that you want. So it's already an algorithm somewhere. Maybe finding it's under search algorithm or something, or sorting algorithm or something, but you don't even know that, right? But you
Yes.
actually do
Sure.
it because it's part of the task, it's part of the jobs, right? So if you have an idea or you've built yourself to know these different algorithms, and we are going to kind of list them. So these different algorithms that people use or that you can use every day in your job, it's going to be great because at this moment, you're not just going to be writing guesswork jobs, right? Or guesswork in your task. You're going to actually know the different ways to make it better, different ways to have that big O stuff, at constant level. Because now you know, okay, unlike before that you don't know that you're actually writing algorithms, but you're doing it. So you may not be doing it in the best possible way, and that can cause an issue later in your code. So it's important that you get the knowledge of data structures and algorithms. And because they take time, it's good that you go on them one after the other. Take it at your own pace. All right. So thank you very much for that clarifications. I have another question here, which is, in your experience, how often do backend engineers need to use advanced data structures and algorithms in their daily work? Now, this question is coming from the aspect where you're going to be given a data structure and algorithm test when you want to apply for a job. During the interview process.
Hmm. Yes.
And now, when you get to the real job, you no longer see these algorithms. So they kind of give you, excuse me. So they kind of give you maybe crawl tasks where you have to read data from database and send it via API and stuff like that. So the question is, when do you actually use it? In your experience, have you used an algorithm and data structure before, and then you say, "Oh, this is the algorithm and data structure that I've been learning since. This is where it is applicable. This is where it is useful in this my job." Right? So has that ever happened to you before?
I mean, as I said, it happens. It still it happened. It still happen. Of course, it's not on a daily basis. Not that every day I need to implement an algorithm or I invent something new. But it happens. And again, you know it will happen only if you know a bit about them. You know about what they are. If I can mention some of the, let's say, more advanced algorithm I use for sure. I had to use the topological sort to scheduling we had to implement like a kind of scheduler for task priority with dependency and all these kind of things. And
Mhm.
that's the topological sorting was the answer. And not always you want to use an external library that maybe as to do something similar or do in a way that it's more complex than what you need, or sometimes even implementing a simple algorithm like, I mean, for me, I call simple, but because for me, it's not nothing super fancy implementing something like that. It's not. It's. I mean, once you know about them, it's not rocket science to implement about that. Or sometimes it happens also to me to do to notice that, I mean, not to notice, you have a problem, you run your business logic, and especially in these medical devices, I mean, the environment we are working on, we are very limited with time constraint, because when our
Mm,
algorithm are running, you can imagine that there is a patient that it's on the couch and is waiting for the treatment, and in the meantime, our algorithm needs to run. Now I don't go into detail, but just to let understand, it's critical that the time. I mean, you have a person that is waiting. Just your algorithm to run on the couch and the way to be treated, and it's not comfortable to wait longer. And
mm,
in this loop of algorithm, every possible optimization can can be significant, no? And then it happened that we had a really core part of our of course I cannot go into precise detail, but we have a really specific part of our algorithm that was time consuming, because
mm,
what we were using basically a brute force approach with some kind of nested loops that were doing the job. And I could really save a lot of time and optimization by using a union find algorithm. That it's basically also a kind of graph algorithm that it's able to combine pieces that, I mean, are pieces of the images that are connected together in some way. And instead
mm,
of doing the brute force, that iterating over of these pieces of a region of images and trying to combine them, this algorithm could do this in what is called the linear time. So basically, I was analyzing the structure one by one and connecting them on the way.
mhm,
And that's to make just two of the examples, but the thing, the concept for me, it's really, and if you talk with another person maybe different than me, that is working on database on database implementation and things like that, it will start
mm,
talking about that that it's important that you know about B trees or other indexing data structures, and then tree based structure, and that's to say that if you don't know about this concept, you will don't know where to where when and where they are useful, and also, I mean, even coming back to me, it's not only about doing this kind of, of optimization, but also in this business logic development, especially in image processing and computer vision, there are a lot of structures, data structure that keep these pixel or images to processing, that are basically tree-based data structure. And also there, sometimes, most of the time, it's fine to use what your library provide, or what other people already implemented. But sometimes you want something more custom, you want something more specific, and then you need to take this stuff and slightly change or modify things. And you need to know about how these things works. And having a basic knowledge of algorithms, and how they work, it's what's allow you to do this kind of task that for me are very interesting. You know, as I said, it's also depend a lot of which kind of backend developer you want to be. If you want to only be the one that I don't want to say that it's a simple task. If you want to be only the one that integrate existing solution and has to maybe use API or wrap API to build uh, REST API, or interact with database, with, I mean, if you want to be that kind of backend developer, maybe you don't need really to know all advanced algorithm data structure. But if you want to do more, or to expand your field of things you're working on, then you will. I mean,
yeah, that is quite honest enough. So the general answer is that it depends, man. You've really broken it down. You know, giving us the example coming from the medical stuff that you're working on. So it's awesome that You know, it depends on the kind of backend engineer that you want to be. That's really great. So if you want to be a backend engineer that builds easy stuff and just use wrapped APIs, you know, connecting to
Hmm.
other people's
Yes.
API, kind of making your own API to work, then it's fine. But if you want to be a backend
Yes.
engineer that, kind of build custom stuff and,
Hmm.
get into the real world of programming, then you definitely need to know algorithms and data structure. So like you said, the answer to the question is yes, you have used data structure in your day-to-day work, and it's beneficial that backend engineers get to know them, and also depends on your job and basically the kind of backend engineer that you want to be. I really like that, and I think it's a time for people to reflect on the kind of backend engineers that they want to be. If they are
Yes.
looking
Exactly.
if they're looking at skipping data structures and algorithms, they really need to think twice what kind of backend engineer that they need to be, that they want to be. Okay. So thank you very much for sharing that. And we'll move over to the next question. So
Hmm.
could you share some examples where deep understanding of data structure and algorithm has significantly improved the performance or scalability of your system? So I believe that you actually shed light on this when you mentioned, the medical systems that you're working on, or maybe for those guys that are working on database systems. All right, talking about B trees, talking about BS trees. Sorry, B trees,
Hmm.
and then talking about some of the indexing data structures that you mentioned. Okay, so that basically helps in answering these questions. But I still want to ask, maybe if you have something else to share in terms of at what point that your database, your data structure and algorithms knowledge helps in building a scalable system or a more performance system, right? So if you don't, we can move on to the next question. But if you do, it would be nice for you to share.
Yes. I mean, I think the example I did before was quite in this direction. No, it was really in the direction of improving the performance, and in that case it was really, I mean, it's not in a case like that when every second is important. If you can do a slight modification of your backend logic and drop the running time from 30 second to 15 second, this is I mean, you can imagine the impact on the on the user that this thing has, no. And as another example, I mean, sometimes it's also changing the. I make it now. It can make me easy to talk about this imaging processing stuff, but also there. Simply change the data structure that was used to, because in image processing it's often used to do this multi-scale representation of the image. So you start with the high resolution images, let's say it could be 512, 512, and then you go to 156, 256, and then you build this kind of pyramid of images where you do basically the same analysis on a smaller scale. And there in one of these algorithms that were processing these images, the simple use of dynamic programming to not recompute things multiple times, and that you can basically go through this level one by one and reuse the computation from the upper and down level, also improved a lot the performance of the system.
Mm,
But it's again it's if you don't know these kind of things, it's hard to think about where when you about that you could do this kind of optimization and save time, no.
Yeah, so basically, for you to be able to implement such kind of algorithms or such kind of task, you need knowledge of it. So it is clear that you need a wide knowledge of such kind of tasks, like image processing. You mentioned, building medical systems that requires, high level of, in terms of the time, it needs to be very short, like seconds. And if you can increase, the number of time, or kind of reduce it, if you can reduce it from, let's say, 20 to like 5 seconds, that's going to have lots of impact. And that's where data structure and algorithm comes, because number one is going to help increase the efficiency and the scalability of your system. Since you're no longer you're using, like, if you can get it to constant, it's going to be very, 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 very good. All right, so that gives us a kind of idea around how important data structures and algorithm knowledge is for backend engineers. Okay, so at least people now understand that first they need to determine the kind of backend engineer that they want to be. And if they know that they want to be a backend engineer that needs algorithm, then they should focus on learning algorithms and data structure. But if they want to be the kind of backend engineers that kind of wrap around people's API and use people's tools to build their tool, which is still fine, then I don't think they need much of the data structures and algorithm knowledge. Okay.
Yes,
Now we
it's
have another
well summarized.
we have another question here, which says, what are some of the pitfalls that backend engineers might face if they lack a strong graph of data structure and algorithms? Okay, so let's assume that these backend engineers, they want to be great backend engineers. They want to know these things. Okay, but
Hmm.
maybe they don't have the knowledge of it now. All right, what are some of the pitfalls? What are some of the problems they are going to encounter? But let's say, for example, if somebody was in your role and the person doesn't have the kind of data structure and algorithm knowledge that you have, what are some of the problems that this person is going to face?
I mean, the main the problem is that I mean, the problem that I see is that you will be less capable to make to make an impact in your daily job, basically, and you will be less able to contribute to technical discussion, to technical conversation about what we are doing. You will be limited, in at least in what we are doing. It's very I mean, it's very very important. It's not that when you are talking with colleagues, they start every time to explain you things from the scratch. Or I mean, there is a common vocabulary or a way of talking about this concept that people give a bit for granted. It's not that they go back and and explain you what a graph is, or what a tree is, or what how an index works, or these kind of things. No, it's assumed that at certain point you know about about this stuff, no, and if you don't know, you have to learn afterward, and yeah, either you learn when you need, but it's worst, or either you try to be proactive and learn things in advance, no.
Mm.
And I think
Yeah, so
for me the approach of learning things in advance feels much better. You don't have the pressure. You don't have you can, yeah.
yeah, so you already summarized it all. So if you are looking to become, a backend engineer that needs algorithms or that works with algorithms, so you definitely need to have known it in advance before even getting there. Okay, so that you can be able to kind of contribute to conversations around what you are building. You can be able to at least have a fundamental knowledge of what is happening first, before
Yes.
you start looking at how you can solve the challenge, or how you can kind of build the system. Okay, so like you mentioned again, it is also good to actually learn these things advanced before you actually get to the task. Okay, so that at that
Yes.
point you don't slow your teammates down when it comes to asking them questions. They can just tell you something in like code, and you quickly understand it because you have advanced knowledge around that kind of concepts. Okay,
Hmm.
so the pitfalls are that one, you won't be able to contribute to technical discussions. You won't be able to make suggestions because you don't have general idea of what is happening. Okay, and that can be really bad if you are a software engineer and software engineers are having discussions and you're not able to contribute. It doesn't sound good. So definitely need to put up your learning shoes and start learning your data structures and algorithm now before you actually get the job. Okay, so thank you very much for giving us that insight. And the last question basically is around, now we know that data structures are important. Okay, if you want to become that kind of backend engineer, I still have to put that because now we now have two types of backend engineers, right? If you want to become if you want to become that kind of backend engineer that needs algorithms, right? Now we want to know from Fernando the data structures and algorithms that we can actually start with. That is one question. What are the top five data structures and
Hmm.
algorithms that we need to learn now, or that we can start learning now? And the next question is, what is the strategies for learning these things? Because I consider them to be very hard, all right? I've learned in school as a student. I've also tried to learn them myself, using YouTube and some paid courses, right? And what are some of the strategies that you use to be able to learn them? Okay, that is
Hmm.
the next question. And then the last question is if you can share some resources, right? You know,
Yeah,
some
sure.
resources where you can go and kind of get the materials to learn these things. It will really be great. Okay, so that's three questions in one. First, what are the top five data structure and algorithm that we need to learn? And what are the strategies that we can use to kind of learn this faster? Or maybe even if it's not faster, but at least what are the kind of strategies that we can use to see results in our learnings? And the next question, what are the resources that you can recommend that helps
Hmm.
you in your journey?
So, I mean, if I can start answering your questions. Yeah, first of all, let's distinguish between data structure and algorithm and algorithm design method. So, if we talk about data structure, I think the apart from the very basic ones that I mentioned before, that are arrays, lists, and queue stack. And then, of course, hash table you need to know, and trees and graphs. That are the most important data structure.
Mm,
And then, if you go to algorithms, there there are most common kind of algorithms are sorting or searching algorithms. And but also there is not that you need to know back and study how is bubble sort implemented, or how to it's in the selections. I mean, it's nice if you're interesting, and it's think always a good exercise to know about these things, because they are implemented with common programming techniques.
mm,
But for example, already know that merge sort use divided conquer, and what is divided conquer, because they are really general programming paradigm. It's not that you think divided conquer is something that is helpful only for implementing merge sort, or you can even you can really apply this technique everywhere. And yeah, if I would mention what to learn, it's yeah, sorting, searching algorithms, and then when it comes to tree and graphs, breadth first search and depth first search, for sure, that are the very basics. And yeah, I wouldn't say you need in all the cases to know advanced graph algorithms. I know that can be complex, or but well, really a lot of graph problems, or general problem can be solved with basic techniques like BFS, or DFS. That's
Mm,
uh, that's the basic I would suggest everyone to know. I mean, also binary search, searching algorithm. I mean, of course, the linear search, binary search, how to implement basic binary search. I mean, most of the time, you can use existing library to implement binary search, but not always the API fulfill your purpose, and maybe you need to implement a custom. I mean, there is no way that a software engineer cannot implement a custom binary search algorithm if it can save really a lot of time and optimize performance. And
mm,
yeah, the way the things, how do you learn this? This is a good point, because I think it's also it a bit depends on I've seen different kind of people now, and I personally am the kind of person that like books, for example.
mm,
And I like reading books. I go over there multiple times. Maybe first time I try to have a high level understanding of things, then I go back a second times. And in any case, what helps the most when learning this algorithm data structure to really understand and retain the knowledge is basically implementing them. For me, there is no shortcut to this. I mean, I found this is also a good way when you want to, let's say, learn or get more proficient with a different programming language. I always have the excuse to go back to, to this kind of algorithm and implement with the other language. So I do two things at once. I learn
mm,
better the syntax of the other language, and I again reinforce my my knowledge of algorithms and data structure. Yeah, and I lost the count how many times I implemented these things. But it's not that you have to do this. It's simply this is something that more I like to do. But at least once you think you then you really see how, because it's it's like kind of reading about the concept. You think you understood the concept. You think you are familiar with this. But when you go implementing the concept, then you really see, okay, oh, this I maybe I didn't got how it was, and you go back to reading about that step and to actually implementing it. So
mm.
for me, and but I know that also there are people that like more to have learn by videos, and there are also there many courses now. It's are available also from I mean, popular US university, like I've seen this kind of courses on Coursera, for example, and they are some of these courses are quite good. I can think about the one of Sedgwick. That it's I loved also the book from him, and
Mm,
they are really good courses. Of course, they are the only drawback of this kind of courses that are they are often let's say focused on one programming language. And maybe if you're not familiar, let's say, with Java, and the courses is with Java, you can struggle a bit more. But I think this is not so limiting, because algorithm data structure are kind of language agnostic concepts. So maybe you cannot understand the detail of the specific implementation, but you should be able to grasp the basic idea, and then implementing your own language.
yeah.
So if I would say how to learn, it's book for me, book, or video courses, and then most important, implementing the things you're listening or reading about. Otherwise, your knowledge will be always on the surface. It's
Exactly. Yeah. So you mentioned, reading books. Is there like any book that you can recommend? Do you have anyone in your mind right
Yes,
now?
sure. I mean, I have that's depend on which level you are. If you are really a beginner, I would suggest a simple book like Grokking Algorithms. That's really good for a beginner. Or another one that I found more recently. I think it's a common sense guide of algorithms and data structure that it's also brought in a simple way. It's adapted to beginner. And once you, if you are already in a more advanced stage, or once you are okay with this basic level, if there is only one book I could suggest, it's the Skinner book. There is a book. It's called the Algorithms Design Manual. That it's a red book by U.S. professor Skinner. It's pretty famous, and if I have to suggest only one advanced book, I would say that one, because this book has two parts. One is the first part. It presents all these algorithm and data structure in a really structured and for me really essential way. All the algorithms are really detailed. In a language agnostic way, but in a way that you can read the book and implement the algorithm in the language you know. And in
Yeah.
the second part of the book, I like even more because the second part actually contain for each algorithm data structure a list of possible use cases where you can use this algorithm data structure. And that's
Mm.
go back on the question you did we discussed during our talk. No, uh, it's like a manual where you can go there and see, oh, in this use case, this algorithm could be helpful in this other use case, and it's really handy. It's like a dictionary of where you can see algorithm data structure and where which context they can be used, and it
Mm.
makes you have an idea. And there are also a lot of anecdote of practical use cases when he used algorithm data structure to improve the performance of the system. Going back also to the question you asked me before, so it's really a good book to read. I would suggest everyone to read that book.
So algorithmic design manual. So I'm getting that book.
Yeah, the algorithm design manual. Yes, yeah, that's the book. That's for me. That's if I have to say only one book, I would say that one. Yeah.
Nice. All right. So you mentioned a lot basically on this last question. So you mentioned four algorithms that we can start with. So you mentioned sorting algorithms. I know there are lots of algorithms that falls under sorting algorithms, but at least the first three, if you can learn the first three, it's fine. And then you mentioned searching algorithms like um, breadth first, BFS, and other ones. And then you
Yeah.
mentioned
Yes.
three algorithms, and then you mentioned graph algorithms. So that's four of them. I think some people, in terms of strategies to learn these things, some persons actually prefer books. You know. But I think I prefer both video and book. So what I do with video is I get kind of a brief concept and how it is implemented. Books I kind of get depth of these different algorithms, right? And then the next thing that you mentioned is implementation. Implementation is actually deep because if you just read these things and not implement, I don't think you actually grasp them properly. I don't think they're actually going to stick in your brain properly if you don't implement them. So always implement them, even if you seems like you know them, kind of always still
Yes.
implement them again and look at different ways that you can implement these algorithms. And I think that is some of the things that I missed when I started out learning algorithms, right? So I just read through them and watch video, implement it once, and then move to the next one. I think that's not a proper way because because you need to always repeatedly or continuously implement each of these algorithms so that they don't go off your brain. Yeah, and for some of the resources you mentioned, Grokking algorithm, I think this is a very popular one. So it's awesome that you are mentioning it. And then you also mentioned algorithm and data structure. I think I have this second one, but I'm going to get this third one, algorithmic design manual. It seems like a good book from what you've said. Okay. All right. So that answers our last question. Thank you very much. This helps us align with our educational goal, which in the program, the Mastering Backend Academy, we are going to try to teach algorithms and data structures, and we have top four data structures that we want to cover. All right. So thank you very much for coming into the podcast. I don't know if you have any resources that you want to share to our audience, or maybe where they can find you on social media. If you have a newsletter, we have a Twitter page, which I know you have a Twitter page. So just share the link and where they can find you. Or do you have a
Yeah, yeah,
course
sure.
we can kind of use to learn this from you?
I'm working on courses and books, but it's I cannot. My goal would be I'm actually working at a small book about recursion. You know, that's because I don't want to do big courses or books that are overwhelming. I prefer trying to work on a small book that focus on one small topic. That was more my idea. So I'm working on a book on recursion, and in the meantime, I'm working on my big project that is working on a book on not and system design is not. I mean, there is also algorithm data structure there, but that's it's more for more experienced engineer and to like all the concept that you need to pass these the system design interviews and these kind of things. And yeah, but I also have a weekly newsletter that is called Polymatic Engineer, and I write every week there about algorithms and data structure and backend concept or system design concept, distributed system, all these kind of things. Now it's 2 years almost that I'm doing this newsletter. I got more than 80 issues, and I mean references are pretty good. I mean I get good comments by people about my newsletter. So if you want to subscribe, feel free. I mean most of the issue are for I give for free. I write for free. And yeah, on the social I'm active on X, all the Twitter and the LinkedIn. You can find simply typing my name. It's Franco Fernando. So and I write almost there daily about the algorithm data structure, backend, or what I'm doing. Feel free to contact me. Also, if you need more information or resources, so if you have question, I'm usually answer everyone. I mean, I'm not. If I don't answer you, it's because in that moment I probably have too many direct messages in my inbox, and I don't even have the time to check everything. But believe me, always answer everyone, even if with a bit of delay.
Yeah,
So I'm happy when I can help others out. Yeah.
yeah, awesome. Yeah, so I just checked out your newsletter. It's awesome, man. You have over 20K members, and I see the kind of topics that you write about it. I'm going to live here, actually. I'm going to be reading through all these and then learning from you. So you can also subscribe. I'm going to add the links to every of these on the video descriptions. Okay, and also I'm going to try to make sure that The links are where you can see them. Okay. So, guys, thank you very much for joining us on this one, and I'll see you again on the next episode.